So let's take a look at the cross slide. So this is our cross slide, and this controls our movement in and out towards the chart, our x-axis. Now our divisions on here are in metric, so that's not a problem. I'm going to be doing lessons in metric and imperial. We don't always rely on these. These are great for roughing carts and for moving a rough amount. But when it comes to accurately controlling our slides, if we don't have a digital readout like we don't on this machine, we'll be using a DTI to get those accurate. So we can produce very accurate parts on any machine by using a technique I'll show you coming up using the DTI. So this is the cross slides, and this is how we're going to be measuring our diameters when we're machining. Now with lathes, although we're moving this 0.1 of a millimeter, it's actually only moving half of that. So whatever it says on this dial, the actual machine is only moving half, because with turning, we're taking off from both sides of the diameter, not just one. So if we wind this in 1 millimeter, it's going to make our diameter 1 millimeter smaller when we take a cut. But the cross slide only actually moves half a millimeter during that cut, because it takes off from both sides of that bar there. So this wheel controls our main saddle movements. Now it has also got a scale on the back there, you can just about see, but we don't use the scale on this handle. That's only there for reference as a guide. You'll find we don't use that at all. We'll be using locks on the bed and the compound slide to give us our accurate on the lengths there. So there's a little bit of play in this, which is great, because we do need a little bit of backlash. All machines have them, but a little technique from when we're just nudging this along, we can play off the backlash and just nudge it like that, and we get a feel for it after a while. And you can nudge off a couple of foul when you're facing off a shoulder just by tapping that against the backlash like that, and it just nudges the saddle along just a very small amount, which is normally all we need to be able to move it. And you get a gauge for it after a while. You can sort of give it a couple of taps and know it's going to be moving around about 0.1 of a millimeter or 0.04 of an inch or whatever. So you do get used to a feel when using this wheel, and the feel is very important on manual machines. So when we come to the compound slide, now the compound slide is usually fixed and it's parallel to the machine, such as it is at the moment. But by undoing this bolt here, and there's one at the back as well, we can move it to a set degree to be able to turn tapers and chamfers. Now this scale on the bottom here is the degrees that it's set to. I tend to not go by that if you're looking for an accurate scale. And what we're going to do later on in the course is we're going to talk about sine bar and slips. So if you have a sine bar and slips, you can use that to set the compound side accurately, and I have a theory lesson on that later in the course. But for now, to get a rough eye, we have these degrees written on here. We can turn it to whatever degree we want after we loosen these two screws, do the bolts back up, and then we can set it to whatever degree we wish. But like I say, it's not highly accurate. It would be maybe within 1 or 2 degrees if we set by eye that way. Ideally, for an accurate taper, we would need sine bar and slips to set the compound slide to a set angle. So our compound slide also has a scale on it, and this one's in metric. And as you can see, one complete large division there is 1.5. So what this does is this indexes our compound slide. Now we use this a lot to gauge our lengths. When we're measuring our lengths and we want to remove an extra 0.1, we would move that, then lock it off, and then we would be ready to take our next cut, and we know the length is moved by that set amount. If you wind any of these backwards, we have to remember about the backlash. So let's say that's zeroed on my part there, and we've got that zeroed off on our scale. So if I'm going to retract it, I'll retract it, then wind it forwards until I hit 0. Never go in, then wind it back until 0. You always got to come past it and wind it forwards. So before you start cutting, you always want to make sure the last movement you've made on any of the dials is to wind it towards the part. So that gets rid of any backlash. If I don't do that, and it's like that, it's going to jump back. as soon as it starts to cut, and that slack on our lead screws is going to fall back and it's going to push the tool back. So we always got to make sure that these are operated in a forward motion when we're cutting. When we wind it back, always go forwards again, come past where you need to go, then wind it into your point then. So you always come past and then wind it forwards, and that works on the same on all slides and the same on the milling machine as well.